Excellent connection. One moment. Okie dokie. All right, so I will be very brief in the introduction. As always, thanks Dreams of Digeo for hosting the Jug Milano. Thank you so much. And also hope that you can appreciate the fact that they have open positions, so don't forget to check out their QR code. A big thanks to the speaker that I will introduce briefly. Just a reminder, don't forget to subscribe to our mailing list, to our YouTube channels. Later I will have the raffle for the idea, so it will be the last raffle for the year. My suggestion is to subscribe to this channel, because if we have any leftover licenses, this is where we are going to raffle them. And as usual, also tonight we will see both sort of like a technology and application, but my invite is always open. If you have use cases, things that you want to share, that you do in your job that has relation with JVM, please feel free to submit the CFP to Jug Milano. We have actually a little backlog of Italian speakers for the next year. So our best intent will be to flush this backlog with great interest throughout the year, but then don't hesitate, because indeed we are always looking for speakers. And tonight, thank you, Simon, for joining us. I will leave this to you. Thank you again.
Thank you. And a big thanks to Matteo for organizing all things around this. Okay, so today I thought I'm in Milan, so would be the best to talk a bit about cafe. I know you have great coffee in here, so I thought it could be a nice use case. So it's a simplified use case, and I will introduce you to the topic of planning AI. Planning AI, we just have seen in the topic of the LLMs that artificial intelligence is a broader scope. When we talk about when we talk about planning AI, it means that it's an area which is part of artificial intelligence, but it's in the area of scheduling. So that is scheduling planning. That's another part, so it has nothing to do with machine learning or large language models. But it's a really interesting one, as there are a lot of use cases for planning automation. My name is Simon Tiffert. I'm based with my company in Germany, between Cologne and Frankfurt. I'm founder and CEO. I have 20 years of experience in the Java and web ecosystem and was in different roles, so not only development, but also in different roles. And 10 years ago, I found this project, which was called Rules Planner at that point in time. It moved on to the name Opta Planner, and the latest fork is Timefold. And it's really something which can help you, support you in different things. And I really fell in love with it. So I founded my company and really focusing on consulting and training on this technology. Okay, let's see what we have as an example for complex planning. So imagine you have a cafe and you have different roles. So you have a barista, you need someone in the kitchen to cook some things, a cleaner, a cashier, and maybe there are more roles involved. You have multiple days in the week, and then you have your shifts. So someone needs to be assigned to the things, but they don't have a regular pattern. So you see, sometimes you have like more people coming, and so also on the weekends there are more blocks needed, and some people just need to have smaller shifts. So you have a really irregular pattern. If you have just a repeating pattern, it could be maybe simpler, but if you have this pattern, it already looks a bit more complex to be assigned. And then you have employees working in the company, and they are, with the green ones, free available for work. They are sometimes non-preferred, so they say, yeah, it could work, but maybe not the best time to work, or they could have a day off. So that means, they are not available for work. And they also have different qualifications. So some are barista trained skills. They can overlap. So some also have skills that they can work in the kitchen as cleaner and so on. So that is basically the set which we discussed today. But as said, it's a simplified example. And when you see on the planning, it means you have scheduled work. So it's describe what needs to be done. You maybe have like peak hours, so more work to do. You need to see how that fits in. You have like different roles. And on the employee side, you have the availability, you have contracts, and contracts can mean you have a number of hours per week to work, or you have like a monthly amount. So that can be different from contract perspective. Also, like there are things like what time of rest do you have between, what is your holiday times, which you need to be planned in, and yeah, what are the skills of the employees. And then things can happen. So someone can call sick, and then it's a planning in the morning. What can we do when someone is not available? So how can we replan the day? What are our options? And when you have a complex schedule, it's a lot of work to reschedule. Sometimes for some plans, not for this one, but for other ones, it could mean that people work several hours in creating their plan. If someone gets sick and it's a key role, then you need to shuffle it. So this kind of plannings help you when you automate it to quickly rebuild a new schedule. For example, someone is suddenly not available, or it can mean if you not just have one cafe, you have multiple cafes. That can mean you also have a travel time between. So someone works some hours here, needs to clean some things, and then travels to another location in the city. So that can be reasons when you are also shifting like from one to the other, and then you have a travel time in between, which you also need to plan because at that time he's traveling and cannot work. And you maybe have some work to do. And then you think about complexity, because in the beginning it always sounds a bit trivial, also with this example. So you just have one cafe. You need 5 different roles per shift. You have 3 shifts per day, 7 days a week, 10 employees. And then you think, how many possible combinations are these? And then you see, okay, when you calculate it, it's 10 to the power of 105, which means we have atoms in the universe 10 to the power of 89. So that means it's a lot of calculations for a really small example. So that is something which is really relevant when you think about the solutions and think about, okay, is this really something where I can compute all possible options? And even with fast machines and parallelization, the numbers quickly grow if you have like real world examples for this type of problems. And then it's like, what are these problems? Planning problems are large scale and NP hard. That means every single assignment, so when you say we have a shift plan and we assign an employee to each of these shifts, that is quickly calculated. That is really quick calculation that doesn't take long. But if you want to calculate all of these dots, all possible combinations, that takes too long. So it's not something which you can just calculate. So you need a way in finding optimal solutions in this planning scope. And how do you find optimal solutions? In a way that you say, okay, we go basically up the hill on the things, but it's not two-dimensional. There are more dimensions included. That means like here, the white flags are local optima that are maybe good solutions, but maybe not the best solution. With this type of algorithms, it could also mean that you don't find the best solution. You have an amount of time, you have some randomness inside, and in this time, it tries to scan the third space, and based on intelligent algorithm, it tries to find the best optimal solution in the available time. So that's like what the algorithm try to climb up the hill, and when it goes steeper up the hill, that means the solution looks better when you go steeper up the hill, but you also have this phases where you also need to go down the hill again, and that is a complex thing because you don't know where to go and your third space is just huge. What is this solution later based on? It's based on 2 phases. The first phase is called construction heuristic, and the second phase is called local search. A construction heuristic initializes a solution so that a solution is filled up. That means for each shift, there's an employee assigned. It tries to build up a good solution, but the algorithms are not as good as in the local search phase. But they are a quick start. If you go for like swimming competitions, you see someone jumping into the water. That means he really has a quick start but it will not reach the other end. So that is like the construction heuristic. They assign values. It's like sometimes you use greedy algorithms, like algorithms like first fit decreasing are used in construction heuristic to quickly initialize a solution. And then comes the local search, because the local search is also backstepping, like changing things. First fit algorithms or something just go forward and just assign the next value, but don't go back if something doesn't look that optimal. And the local search algorithms, and that are ones like late acceptance, taboo search, simulated annealing. These type of algorithms are really powerful in then finding the optimum. And these algorithms are built into Timefold. And Timefold also has this incremental score calculation. That's where rules comes in, because for each dot you calculate, you need a way in calculating the whole score. So you need to calculate for each shift and see what are the patterns. For example, if you want to see, okay, he's working till late night and what is the next morning, that means you need to find like 2 shifts which are assigned to each other, and the same employee shouldn't work directly, or he cannot work on the same day. And that are things which you can calculate, but maybe you don't need to touch the full solution. If it's something which is a change on a Monday, Tuesday, maybe it doesn't affect the weekend. And that's something you can detect, and based on that one, you can do the incremental score calculation. What are the benefits of Timefold? So Timefold is a framework I'm talking about, and it's like open source under Apache license. It's an active development for over 18 years now. It was called like Roots Planner in before, Opta Planner, and Timefold is a fork of Opta Planner. There are also commercial versions available, like ready-made models in SaaS, which you just can use for like technician scheduling or employee rostering. So there's a REST API. But also if you need the open source core with some more features and commercial support for like multi-core or nearby selection, which can speed up if you have like a large vehicle routing problem, then there's also a commercial enterprise version available. And it's fully in the Java ecosystem. That's sometimes interesting because it's a simple jar dependency. So it's just Maven. It's no local installation, which you see in a lot of tools where you have like core dependent installation or something. It's just a normal Java dependency. And you do like plain old Java objects with some annotations. You have a stream API, and that's all you need to get that things running. It's developer friendly, so you can use test-driven development. Something which in a lot of like research close developments is lacking, that like you just do complex logic things, but on the other hand, it's like it's not tested. With Timefold, you can test on the unit level, so that's really beneficial. Has a great documentation, and you will find a lot of examples. So when you look for Timefold quick starts, you will find a lot of ready-to-use examples, simpler ones, but some for a really good starting point. And Timefold works directly with Java Kotlin. There's also a Python version available. And yeah, it integrates seamlessly with Quarkus and Spring Boot. So that means there are some helpers included so that you need less configuration and you can really use it out of the box. And that's something we will see later on. Timefold runs on, as a Java, all JVM-based environments, and also like Kubernetes OpenShift. As the speed is more in the algorithms, the CPU is relevant, but not that relevant. You don't need a high computing, high-end machine to run it. You can also deploy it in the cloud and use it there as microservice. Yes, it's good to have some CPU power, but on the other hand, it doesn't need to be like a supercomputer to compute these things. So on that one, it's more relevant what the algorithm is doing. And then let's see how really is it configured. So what you need to do to really build up a project based with Timefold. So you have two things in here, two classes. One would be like your planning entity, like your shift, and that you need the annotation planning entity. You have a planning variable, which is, again, in here, something which is like later on like the employee. So you have a lot of different variations for this one. So the fixed things are the entities that are already predefined. And then you have a set of variables, and which variable is assigned to this entity is a thing which Timefold plans later on. You also need planning IDs, so that Timefold has a way in differentiating the different entities from each other and also the planning variables. All together is wrapped later on in a planning solution, and then you're ready to go with the modeling. So it's really close to what you normally do. A lot of frameworks in this area are close to operation research, so you need a lot of mathematical knowledge to work with these. But if you come really from a domain modeling with Java perspective, it's really easy to get into it and get the first things running with it. So that's really something which is easy to do. And then you define your constraints. And constraints are the limits which are defining what is not allowed or what is rewarding. So it's overall calculating a score on violations, and that can be on different levels. Often you see in here, it's a hard-soft score. That means you have one hard level that are, for example, physical constraints. A person cannot be in 2 different cafes at the same time. So that are physical constraints, but you need to describe it so that the framework knows what's going on. And on the other hand, there are soft constraints that are more like on the cost side. So imagine you have like different people working, but they have different hourly rates because someone is trained as barista and someone is just a student helping to clean up some things, but is not trained in anything. So you have different cost factors for people, or could be a lot of other things. So more the cost things are soft constraints, and hard constraints are often the physical things which are there. And a solution is called feasible when like there are no hard constraints broken, but it could also be that sometimes you have not enough employees. That means you break hard constraints, and then you need to take decisions which are out of the scope of the planner. So that means it can be that sometimes there is no viable solution for a problem. That can also happen when you do it. And then basically it all comes together. So you have the input, so all the shifts. You have basically your employees, which their skills. And then you have domain model, which we just have seen, which is then wrapped up in a solution with a constraint stream defined as Java stream. And then you have in the middle, there is a Timefold solver. So all these things basically you bring together. And this structure, for example, could be just a JSON data set. So you bring in a JSON data set of your predefined information. You have the model, and that can be different data sets with the same model. And then you generate the output. So in the middle is the Timefold solver engine. And you can run it with one problem, but you can also automate it and build up your infrastructure to run multiple input data sets into this problem. Okay, then we will together code a simple example, and we can show you that it's really not that complicated. One question, who is familiar with Quarkus already? Okay, so a few. Good. Then, first thing I do is I need some dependencies. So here is just the Quarkus website, and there is code Quarkus.io where you can just generate a simple stub for your project. So you just define the dependencies. So for me, I just go in here and say, and I say, okay, so I just give it a name. And what I want is, I want REST, but with some JSON. So I need Jackson. As one of the libraries, there are a lot of dependencies, but for my project, I want to build a REST service. So I just have a JSON model. I want to simply bring in my domain model. Then I want to call Timefold. So let's check what we have on Timefold dependencies in here. So we also go for Jackson because then it can also directly output some information as JSON, and we go with the Timefold core. So that are the three things I need. And then, yeah, just download the zip file. Okay, so next thing is I will open that project, and as I define it as Maven, so spinning ball. Okay. Let's reopen it.
That's live demos.
Yeah, that's live demos. That's a fun. Okay, so you try it again. So we just select the POM file, which will completely open up our full project. So that's also something which is really, really nice. So you basically have it directly running. One thing, I have the Timefold dependency in, and as Timefold is already configured and tries to search for some things, I cannot start it up now. So what I need to do now is to build up all the Timefold model solution constraint so that it's basically running again. If it's just a default Quarkus, I can now directly launch it up and start it. So on that one, we say we have Café domain. So we build up a package, and then we just define our first Java class, which will be the shift. So that is something we have seen in the initial one, and it's not that large, right? Let's see.
Presenter mode.
Yeah, I more go with this one. I changed it before. We go with this one. Okay, so we have the shift, and we now said it's a simple POJO. So we have in here the shift, and I take a shortcut in here because what I need is an ID so that I can say planning ID on that one. The shift overall, as we have seen, is a planning entity. And then what we need for shift is that it has start time, duration, and we want to have some skills which are needed to fulfill that skill. So it's a start date time. Then we say it's a duration which I want. And we set the skills are, for me, at the moment, just a simple string list so that I can work with it. Normally, you would model it differently when you build up a full one, but for the moment, that should be fine. And later on, I want an employee with it. So that is basically the main structure we are starting with for our planning entity. So I just want to generate constructor, but it can be an empty one. That's just needed for the serialization process. And yeah, we want some getter setters for the moment. And then we create the class employee. Just go back, because employee will be our planning variable. So to understand on that one means we have like the shift, and we have the employee, which will later on, you will have a lot of different employees. And what it does with the shift are predefined. So you have a set of predefined shifts. You have a set of employees. At the beginning, it's null, and then it will iterate through all the different employees, but in an intelligent manner. So that is basically what's happening with the planning variable. So let's go to the employee. The employee is a planning variable which don't need any annotation besides the ID. So we also have a list of skills for it. And we want to see that like he's working only on specific days for the moment, which are the work days. Okay, then also on that one, there's an empty constructor. And that one. So that means we have these two. And what we now need is a planning solution. So we need to have something which encapsulates all these things so that we can basically have a list of all of these. That means we have a schedule that is a planning solution. What it has is a list of shifts. And okay, so that are like just the list. So later on I will have a JSON structure prepared, which I will just basically load into this predefined domain as we have Quarkus with REST interface. And then I will have a score. That is a score which I later calculate. So that is something where Timefold will generate a specific score and it can also output it. So here we just say we have a planning score for it. Okay. I miss anything in my quick notes? Yes, I do. So what we need to define in here is that is a planning entity collection property. So we need to tell, okay, this one is the one you need to plan. And on that one means we have a value range. That means that are all the values which can be used in the entity later on. Again in here. So we have this set already. So let's next go and create a constraint stream. That means I want a package which is called solver. And in that one I want to have the schedule constraint provider. Okay, yeah. And what it does, it implements one method, define constraints. So in this one, I'm defining my constraints, and the constraints are defined as an array on that one. So first thing which I do is like I want to match by skill. So I want to have an employee which has the same skill which is required for this shift. So let's say we need a skill and we have a constraint factory which we give into it. Could be named differently. And what we will build up is a constraint stream. So we say in here, we take all shifts, and what we want to make sure is that we have someone with a matching skill for this shift. So what I will filter is we have a shift, and on that one means we want to negate it. Get skills. Contains all shift skills. And so we negate it because we want to penalize it now with just a hard score of 1. And we also give it a name? Yes. Oh. Sure. Okay. So so basically, we just have the method. With for each, we need to have something which is annotated as a planning entity. So we could also go for variables or something. And then we filter out of this stream of all incoming shifts something which doesn't contain all the skills which are needed for the shift. And then, we basically penalize it with hard. And we give it that one. Okay. Next thing we need so that we have something running is we want to move the greeting resource, which is just an example which was coming with the initial project. So if you look into it, we have the greeting resource which says hello from Quarkus REST. I just want to do something to complete it. So in here it's that's something okay, and here we tell him how long it should run, because if we don't tell him how long it should run, it runs forever. And that is something where you have different ways in getting out a solution. So one way is you get every time there is a new best solution, you can grab it and use it, or you can wait for the final solution, and the final solution will be with a termination criteria. And you can terminate by time, that you say, okay, I have a specific runtime, or you can go and say, I want to have something which has a specific score or a difference in score. So you can say, okay, I want something which now has no improvements after a specific amount of time. And that's something which I use in here. So I could also say stop after 5 seconds. What I say in here is stop after 5 unimproved seconds with the solver. Okay. Let's see first if this default, so I'm just using this hello from Quarkus REST, which was there, if that's now working. So we don't need these for the moment. So we have this one. And we also need to start it. That helps. Okay, so let's get a response. And the response is hello from Quarkus REST. So, and that's really, really nice with Quarkus. It works for a lot of things just out of the box, and you don't need to recompile or something. So when you request it again, you don't need to recompile. There is a live refresh built in when you are in the Quarkus dev mode. And that really, really helps when you work with Timefold, because Timefold is Java code. So you don't need to have a full build process or something later on. You can just run it, because Quarkus takes care on having the live refresh also running in the background, or when you do a lot of other things with Quarkus. So I really, really like Quarkus in combination with Timefold. And now what we need is that we have something which starts a solver. So we have seen there's an input. We want an output, and what we build now is, yes, it should consume that one. It will also produce the same. And we want to have another path. I like to call it solve. I also don't like hello as name. I like to more API. And then we say public schedule, because it will return the schedule. We'll later show you on that one. Yeah, I like this. And we will also input a schedule. Not sure if you have seen that one, but when you input this domain object, then you can, and have JSON, then it directly uses JSON to fully populate like the structure in there. So it will just consume a schedule as JSON and run it in there. Then what you need is a solver manager, and that's something which comes into this Timefold built-in support. That means you need a solver manager, which is schedule and UID. Don't like it yet? Okay. Why is it not? Taking it. I want to have.
Is it maybe because it's missing an A? Is misspelled?
That helps dramatically. That's really an improvement. Thank you. And both. Okay. Okay. So yeah, that helps. Then we have solve a job. So it basically means we now create a solver job for the solver, so we can later reference it. That also is on that one. Okay, so then we have the solver manager, and what it has is a builder pattern now in the latest API, and you can say we want a problem ID, and as I don't use it just for demo purpose, we just randomly generate something, and we want a problem to be injected. That's our schedule. So we are done with that one, and we want to run it. And then we want to return the solver job, and that has a final best solution. But that can throw an exception, so we are lazy for the demo purpose and just throw it. That means in here, we request a solver manager, which is part of Timefold. We need to give him an ID so that it can assign it to a specific ID. You can optimize multiple in parallel. That's also possible, multiple problems. That's why it needs an ID. We give it a problem, and we get the final best solution. You could also get intermediate results. So every time there's a new solution, you can also get it. So normally it runs in asynchronous mode. For the demo purpose, I just use it as directly returning, so I wait for it to return, so that I can simply have a REST service with this one running. Okay, then I have an example in here, which is just a JSON data set. So we have a file which we call data.json, and I generated it with an LLM, typically, what you do in current days. What it contains is, we have the start date time. So luckily my domain model matches. So we have start date time for the shift, duration, and we have skills. And this time it's always one skill needed for the jobs. And when I close on that one, you will see there are some employees defined with some workdays. So just ask for LLM to generate it. And now let's go to our greeting resource, which I just call API resource. Okay, and then we see if we can basically run it in here. That means we have the REST one in IntelliJ, and what we can do is we inject data.json so that we see that it's running. Copy in here this one. And now it's running in the background, so hopefully it's running, and it's running already some seconds. That means something's optimizing in the background. Okay, so let's look now at the results. First I go and we look at the log file. What we see in this line in here, it tells if it's too small, solver started, time spent 10 milliseconds, and the best score is minus 280 in it. That means we had 280 shifts in there, which are not assigned. So initially they have an employee assigned with the value null. And then we go through the construction heuristic phase. in 37 milliseconds, and it already solved it to an optimal value with a smooth elevation speed of 560,000 calculations per second. That means it was quite quick to go through it. As it's already a hard zero soft score and we penalize, there is nothing more to optimize. So with this one, we are done. And we can still look at the result, which is this file in here. And we see that was our generated ID for the first shift. We need a barista, and we have Mark, which is a barista. And the 12th is Thursday, so he's not working on that day. And let us look in here. We also have the second one, and also we need a cashier, and it's Mark assigned. But if we look at the time, yeah, it's both at 8 a.m. in the morning. So we are lacking some constraints, and we can quickly add some of these. So what I want in here is something that I say it shouldn't overlap. So we have 8 a.m. and we have assigned the same employee to both ones. So we have the constraint factory again here. Okay, and again in here we have the constraint factory, and say this one means we now want, at the moment we both have both shifts at 8 a.m. assigned to the same employee. So we don't want that a shift is overlapping for that employee. That is now the constraints we're building, so that he cannot work in the two same roles at the same time, because that's our domain definition. So we don't want that we have two shifts which are overlapping. So what we need now is for each unique pair. So not before we said for each, because we just needed one. Now we say for each unique pair of a shift class. And what we then have in here is we have joiners, and we want it for two shifts which have the same employee assigned. And what they want is that they are overlapping by time. So in here we have the shift start time. The end time is something we don't have because we have the duration, so we quickly do it this way. And we add the shift duration. And yeah, then what we have in here is, okay, where's the overlay already? So when we have, like, for each unique pair, that means we have two shifts now, which have the same employee assigned and which overlap by time. And that's something also which is a hard constraint, I would say. Stop it. And we give it a name, which means no overlap. Okay, so now I expect what we have seen in before, that we have Mark at 8 a.m. So let's go and run it again. I just defined 5 unimproved seconds for the small example. Could be quicker. So we have 8, we have Mark assigned, we have 8, and we have Emily assigned. So that's basically working. But there is something else which we can quickly fix, which means there is, for example, we see it on the 12th of December, which is Thursday, if I'm not wrong, right? So, and he's not allowed to work on Thursday, so that's also something which we can add as constraint. As you see, it's often something where you need to add constraints on something. You need to make sure that are really basic ones that are quite fast. Could also mean that you have more logic attached to it. Then you need to be careful to really do an efficient programming. That's also something you learn when you do a lot with Timefold, because as you have seen, like with the initial one, we have 50 over 500,000 calculations per second. That will slow down when we have more constraints, but you need to write really efficient code. It's Java code, so it's quite fast, but you also you can waste a lot of runtime when you're not efficient. For example, if you have a tree set which has a direct access or a hash map where you can have a direct access, or you use a list and stream. So when you build the structures, then you slow down. So that's something which I often see in projects, that you can optimize on these things. We now want to Workday on that one, and as you imagine, this time we always go by the shift, and we want to filter this time, so that we kind of say, okay, every time, in this case, what's the direction? Contains, and we have shift, start date time, day of week. And then we're going to penalize. I don't have any soft constraints for this example, but as said, when you have something which is like a price per hour or something, then you would also have a price function, so you would optimize for the ones which are there. And we have in here the day, workday.
Excuse me, shouldn't we negate this one? Question mark.
Yes. You're right. That's the case when you write tests for the type of things, which you don't do because it's a demo. But that can really help in doing so.
But what I like is very readable.
Yes, yes. Like it was like, if you remember, like initially it was called rules planner. That means the rule base was based on rules, which is also a really nice tool. But you also have the DRL language, which you need to learn, which was for some people who would just have some Java knowledge easier now to use the Stream API on that one. So, okay, so we see 12th is a Thursday, and now we have Sarah working in there. So basically it's working. When you look on the scores, like the local search was not as effective as this really simple example. Real-world examples are much more complex. So you have also much longer runtime. You need to optimize on these topics more. Yeah, so basically that's it on that one. Okay, then as closing, a few insights in lessons. So when you work with Timefold, it's really relevant, the domain modeling. On that one, it sounds quite simple, but in the real world example, you take a lot of time in how could you model it best? What's your planning variable? What's your entity? For example, on shifts, I used a really simple pattern. Normally you have like a shift and then you have multiple people working at the same time. So you, for example, also when you do flight scheduling or something, then you assign multiple people to one flight, and then you have some more, your domain model grows, the complexity grows with this one. And you can model it in different ways. There's not always one way, you can model it in different ways, but one way could be more effective than another one for the algorithms. Also for time modelings, a lot of things are time-based. Also in here we have a schedule, but often it's around time. So you have problems like vehicle routing or something, or you have something like maintenance, and then time is always something you're planning. So also for time, there are design patterns. So when you look in the Timefold documentation, look for these time patterns, because it's quite relevant at the beginning when you start with Timefold to understand how time is planned, because vehicle routing with a chain solution is completely different modeled than this one. Custom expectations, or like how you build it, like we just have seen our REST request, which returned after a few seconds. It depends really what you have on data. It can be several minutes, but when you, for example, optimize like a train schedule for a country that are hours, weeks, maybe not, but like for some cases you have really runtime. Then I have one customer who said, okay, if the runtime is below a 2-digit number of hours, then it's fast. So that means there are quite different expectations. But when you build like a user interface, have that in mind. So you need some way of asynchronously integrate that one when someone changes things. Also, Timefold is able to calculate a score in between, so you don't need to run the solver, you can just calculate the score. So when you do a manual change of the solution, you can just calculate the score of it, which helps if you build a user interface. So it's also quite helpful that not always an optimized plan, because often there is a dispatcher which you are supporting with this kind of tool, so that can be really helpful. And it really depends on the problem size, so there is not one fits it all. I would always say start as simple as possible. Just use the set we just have seen. There are tons of tuning options in all directions. As mentioned, there are different algorithms. We didn't configure any algorithm because there are some pre-configured in Timefold. Standard is late acceptance usage, but you have like others sometimes even more effective in use. So you can change it by configuration. Timefold, I would recommend go with the XML configuration. It's a bit old school, but all documentation, all Stack Overflow posts, when you run a benchmark, which is a tool in Timefold, that outputs an XML configuration. So when you start doing more with Timefold, go with the XML way. It simplifies your life on that one. And then you can change what moves are done. So when you have a solution, you have a change move, which is change one entity, one planning variable. You can do a swap move. So when you have some shifts are at the same time and you just change one, then something is missing, so you run into hard constraint. Then it's more effective to change two people in the same role to maybe have a better scheduler. When you think about school timetables or something, when you have lessons at the same time, it can help to exchange on these things when you run on these. So there are lots of things like run the profiler. When you do some more complex logic yourself, run a profiler. Look where your heat profile is in the profiler. That really speeds up the solution. So that are things which are helpful when you run with Timefold. And what are solutions you can build? So you have like vehicle routing and more complex, like with time windows, with weight constraints. So you are yourself adding the constraints. So it's really something you're customizing the model to the needs. Maintenance scheduling, like you have a lot of tools. Where do you maintain? Who is maintaining the tools on these schedules? Field service routing, so you combine someone who is installing fiber to the office, and you have a lot of technicians all over the country running. Who is going to which location and how many technicians do you need where? You can just run the daily operation. That's a typical pattern with Timefold. But you can also think about strategical things like that. You say, okay, I'm adding some more to see like how many people do I need to do a job or something. So you can also run strategic patterns to find out, okay, how many resources do I need? You can like facility location. You can say, okay, what's my driving time? So you can say, okay, my location can be on different areas. What is the best location to place the next depot for parcel delivery or something? Job shop scheduling, so production scheduling. It's also something where this tooling can really help when you say, okay, on which machine runs what in which order. Also coming when you do like a lot of custom, so when you not run long batch runs, but you want to reconfigure and you have your orders incoming, you have delivery date, so when do you switch production or something, that really helps on this one. And it's Java, so you can integrate with any framework in the Java space for like Apache Camel or other ones to just fetch data, use Kafka or other things. So it's just really easy. Combine it with Quarkus, really love it for these things. That's it from my side.
Questions? Are there any questions for Simons? Don't be shy. Yeah.
More than a question, just a comment. Is about the when you discuss about the time, right? For a real business case and users, the time can have a huge impact on the planning space, because depending on how much is granular. Here we are talking about planning for shifts for humans. Sometimes you are using that for optimizing some process or machine stuff. You can also do this with Optoplanner. What is your comment or suggestion? Maybe it's possible to have splitting the problem in small planning problem to feed another one sequentially to reduce the granularity and this piece. Thank you.
Yeah. So with the time slots, that means you can also have a time slot pattern. For example, when you do a production, there are different patterns, for example, to plan when do you plan a production order. And you can use time slots. So you slide the time windows, and the bigger the time windows, the less you have. And the planning scope you've seen is exponential. So when you not go for like 5 minutes or 50-minute slots, or you go for a second slot, that means your exponential explosion is like huge. So really be careful on time slots when you use them. So that can really help. What else you can do is use a stage optimization. So that you say you use first a rough granularity to get an idea how that could look like, and then use like smaller chunks later on, or a pre-optimized thing. So when you have like different things, it's also happening in production. So you have a long-term strategic planning. That's something which is on a rough level. And then you have the operational daily planning. And sometimes there are different models with different constraints. So you can also run multiple stages of optimization for the same topic, but on different time levels. That can also help to reduce the runtime and make the problem smaller so that it fits better to the runtime.
Any more questions? Maybe I'll just ask the last one. First of all, thank you for the presentation, not only about the technology, but also the application. Especially appreciated that one. Since the first talk that we've seen today, of course, the question of the year is like we've seen LLMs is like a great thing. So I was wondering, what is your perspective, what is your opinion on how to integrate this kind of like planning AI with the hype AI that we have nowadays? So if you have an opinion about this one.
Yeah, good question on that one. So it's really interesting in that space, as everyone doing planning AI, planning optimization say, no, LLMs cannot solve it. Which is on one sense true, because when you have a complex problem, LLMs will solve simple ones already. So that's okay. But with larger ones, a lot of mathematical computation goes into it. So it's just sometimes hallucinating for a best solution. It's not giving you an output. Maybe there's a chance of using it for construction heuristics, so that you kind of give an initial solution, because for the local search phase, you need an initialized solution. That can be one space. It's a lot of input processing. So how do you get like a structured data set? Because you need a structured data set. But if your data is unstructured or maybe incomplete, maybe LLMs can help to really streamline that one, so that you kind of build then structured data, which you then can feed to the systems. Some play around with constraint generation. That you say, okay, maybe this constraint can be generated and you can just describe your constraints. So the code is generated. Currently, Geoffrey Desmet, the great creator of that framework, also commented, even his comments are reproduced in the generated code at the moment. So it depends like how the model is trained. And there is a bit of training data, because there are some examples out there which are probably already scanned, but it's not something which is highly optimized, and there are tons of stream constraints which are already run through that LLM. So on these areas, and also it's explainable AI. So you can later on see what was the result with a planning solution, and you can really get it described, what was basically the outcome. And an LLM can maybe help to interpret that data, so that you can see what is maybe the essence of that outcome, because maybe you see, okay, it's vehicle routing, and you see, okay, in this area, maybe we need more staff, so that we need more vehicles because we are lacking, somehow we don't get a viable solution. So we have some hard constraint violated. What's maybe the best solution to get this thing solved? So that can also be maybe some areas. So it's all around LLMs, I think, in a few, not sure months, years, we will see. But we also bet for seeing more LLM in this area. But for the solving, it's like it's maybe producing the domain models, the constraints, but like the core model, still something where LLMs are not that good.
Impressive. A future of potential opportunities, but also integration of the right tool for the right job, maybe, right? Okay, let's make an applause for Simon. Thank you so much. Before we move, we have one final closing remarks, please.
No, just to say thank you for coming today. Thank you for our speakers for coming also today to share their experience. And also thank you to Hack Milano for the collaboration for this event, because I think they deserve also a huge thank you with some claps. And just to let you know that the pizzas are waiting for us in the canteen, so you are more than welcome to move to the other space. And thank you again.